Okay, this is the last section in chapter 8. This is the word problem, application of right triangle trigonometry. For the warm-up, this is a little bit of a review of the first half of chapter 8. So I want you to, before you start solving, think about what strategy you have to use and solve this. Okay, just a little review. Okay, so do this before we start. Okay. All right, so objective is solve right triangle problems by correct selection and use of the tangent, sine, and cosine ratios. Okay. Right, so this is important concept, the angle of depression and elevation, because in the word problem, it will tell you the angle of elevation is whatever degree, or angle of depression is whatever degree, and then if you get that angle wrong, you're going to get the problem wrong, okay? So the key to remember is that this right here is angle of depression, and this right here is angle of elevation. Angle of elevation is the horizontal line and the line is going up, angle of elevation. Angle of depression is horizontal line and slanted line is going down. Okay, and angle of depression and angle of elevation is always relative to the horizontal line. Okay, so you have a horizontal line and the slanted line is going up, then that's angle of elevation. You have horizontal line and slanted line going down, then it's angle of depression. And no matter how many times I say this, that it's relative to horizontal line, there will always someone who think that this is angle of depression. And this is relative to the straight line right here, that this is angle of elevation. That would be relative to the vertical line, right? Angle is always one of the line that makes the angle have to be the horizontal line, not the vertical line. Okay, now you come back to this when you make the mistake, because many of you will make that mistake solving the problem. Okay, so if the top of the lighthouse is, so this is a practice. Okay, so top of the lighthouse is 25 meters above the sea level, so this is 25 meters. Okay, the distance x between the boat and the base of the lighthouse can be found in these two ways. Method 1, you can use tangent of 2 degrees. So this is 25 and this is 2 degrees, and that's x, right? So opposite over adjacent relative to this 2 degrees, opposite over adjacent. Okay, so that's using angle of elevation. Or you can use tangent of 88 degree. The 88 degree is this one right here, because this is 90 degree and this is 2 degree, this is 88, right? So tangent of 88, then it will be flipped. X is opposite and adjacent is 25. And if you solve this, in this case, this is x equal 25 divided by tangent of 2. So if we put this in a calculator, we have 25, 25 divided by tangent of 2. And you will get 715.9. 715.91 actually. And then for this one is 25 times tangent of 88. And it will give you the same number. Okay, and here at the bottom it says that the distance or this angle is approximation, and this distance is going to be approximation. So in this kind of problem, the answer will tell you to round to the nearest 100 meters, something like that. So round to nearest 100 meters, in this case, this is 700 meters would be the answer. So you have to follow what the problem asks you. good answer would be the boat is roughly 700 meters from the lighthouse. If we say nearest tenth of meters, then you have to give 715.9. It says nearest meters, then you have to give 715, no, actually 716 meters, and 700, nearest 10 meters, then that would be 720, right? So you have to know where to round it based on what the problem is asking. Okay. All right, so here's a practice. Let's just do this. Actually, I want you to think, and then we go over it. The two people at point X and Y sight an airplane at A. Okay, what is the angle of elevation from X to A? X to A. Angle of elevation is relative to horizontal. Going up, this is 35, right? What is the angle of depression from A to X? A to X. Now this one, you only have these angles written. So, but there are programs that will give you these kind of angles. And instead of giving you this, they give you this angle. So if this is 23 and this is 12, that's 35. So this would be, 55. So instead of giving you these angles, they give you this. And then ask you, what is the angle of depression? Angle of depression here from A to X is 35, not 55. But I know that some of you will give me 55 if the only angle given is this. You have to always get the angle relative to the horizontal line and slanted line, never the vertical line with slanted line, okay? So you do this last, okay? Because I don't think it's hard here. And here, this is kind of problem that you need to practice to get angle of elevation and depression. Lines shown horizontal and vertical lines except for the HT and HG are slanted. Give the number of the angle and its special name given. A person at H sights to T. H to T. So that's relative to the horizontal line. It's going up. So this is angle 2. 2. H to G. Okay. So this is angle of elevation. And this one will be angle of depression. So you do these two, okay? All right. And I think you have to identify the angle by number 2. So this is angle 3. Okay, and then identify angles and then what kind of angle that is, okay? All right, next one. The driveway has a 15% grade. What is the angle of elevation of the driveway? If the driveway is 12 meters long, how much does it rise? Okay, so this is another problem that a lot of people get confused. So let's say this driveway is going up, right? Okay, so angle of elevation is this right here, right? And if it says that has a 15% grade, many people think this is 15%. No, this is angle of elevation. The grade is, if this is 100 meter, this is 15 meter. That's what the grade is. Okay, so not this. So now you have to, so let's call this x degree. So we have to use a tangent inverse to get this angle. So tangent inverse of opposite over adjacent, 15 over 100. So we put this in the calculator, and it's not going to be 15%. Tangent inverse of 15 divided by 100 is 8.53. That's the angle of elevation in degrees. Okay, so it's different. So don't get confused with that. The grade and angle of elevations are not the same. And if the driveway is 12 meters long, if this is 12 meters long, about how much does it rise. So now we know that this is 8.53. We can use sine of 8.53 have to equal. Now this was ratio. It was 100 to 15 was ratio. We don't know the length, but now we know that this length, we can get this in length, right? So the hypotenuse is going to be the denominator, and how much go up in meters is going to be y, right? So then y is 12 times sine of 8.53. Now here for the showing purposes I'm using 8.53, but in the test, in the calculation, you put this in here, so it's more precise, rounding. So here you go, and then you have to show that on the paper. Okay, so that would be 12 times sine of tangent inverse of 15 divided by 100, parenthesis closed. Okay, the tangent inverse will give you the angle, so then sine of that angle, enter, and 1 point y equal, y squiggle, because I got around 1.78. Okay, so this is going up by 1.78 meter when the driveway is 12. Okay, so these are that kind of problem. Now you see how things can get a little bit tricky here, right? So I want you to try, is this the last problem? Yeah, I want you to try this for homework. Okay, and this is odd, so there is hot math. So if you don't know what you're doing, try hot math. Okay.